All right, so here's your lesson for finding areas of what are called composite figures, or also called irregular shapes. So basically, there's a couple different ways that we can find the area of irregular shapes. Sometimes when we have a shape inside of a shape, I don't know if you can really tell it from the video, we're kind of showing that this is shaded. So this question would ask, hey, what's the area of the shaded region? So when we have a square on the outside and a circle on the inside. And the second one is different connecting shapes. So this one we have a rectangle next to a triangle, where we could break it up as two, or some of you may still view that as a trapezoid, which is what that is. But a lot of students will look at this as two different shapes, and they find the areas of each and then add them together. Okay, so here's how we find the area of a shape inside of a shape. So what's the area of the shaded region? Well, one way to do it, and I think the best way, is one, you got to know what you have. So step one, you got to know what shapes you have. And when I look at this shape down on the bottom right, I mentioned you have a square with a circle inside of it. Step two, you find the area of each figure. And then think of it as like, I'm going to cut out this circle from this square, and mathematically, what are you doing? It's subtracting out this inside area. Okay, so how do we do it? Well, we first find the area of the square, which is 11 times 11, which is 121. And now we find the area of the circle, which is pi 3.14 times my radius. Now remember, my radius is 4 because this 8 goes all the way across. So this is 3.14 times 4 squared, which is 3.14 times 16, which is 50.24. Okay? So that's the area of the circle. Subtract out the circle from the square, so your total area is 121 minus 50.24, which is 60.76. Get your units, feet squared. That's how we find an area with something inscribed inside of something, and we're finding the shaded region. Okay? Number two. Okay, so number two is where we have this triangle and this rectangle. So this one already has the line drawn. So we basically we find the area of each. So I'm going to call this figure 1, or the rectangle, and we're going to do figure 2. And I'm also going to show that this, you got to recognize that this 5 feet, because it's a rectangle, this side is also 5 feet. That will help us with the area of the triangle. So number one, we take the area of the rectangle, which is 12 feet by 5 feet, which is 60. Area of the triangle, which is base times height divided by 2, which is 5 times 3, the base and the height, divided by 2, which is 7.5. So the total area of this one, we have to add those together, okay, which is different than what we did in the last problem. So the area of this is 67.5, again, feet squared. All right, third one. So here we have, looks like a rectangle, length times width, on top of a half circle. So I'm going to give you a half circle is basically a circle, the area of a circle, pi r squared, divided by 2. So that's the formula that we're going to use for that. With a radius, well, again, this 14 pushes up here, so I'm going to actually put this distance, this radius equals 7, because it's 14 all the way across. Remember, all we need is a radius. So number one, the area of the rectangle, we'll call this figure number 1. We'll call this figure number 2. The area of the rectangle is just 14 times 8. 14 times 8 is 112. And now figure 2 is pi 3.14 times my radius squared, which is 7 squared, and then we have to take that and divide it by 2, and that is going to be equal to 3.14 times 49 divided by 2, and I actually don't know what that is, and I don't have a calculator, so let's just do some math. So 49 and 3.14, let's see, 9 times 4, I'll show you my work here. It's going to take a little time, so you can probably speed through this video to the end if you don't want to see this long division. But so let's see, 36, 3, 2, 1, 27, it's 28.26, 0, 16, carry the 1, 5, and 12, add them together, so we get 6, 8, 13, carry the 1, 5, 153.86, but now we have to divide that by 2, and I'm going to have to do that real quick. So let's see, 2 goes into 15 7 times, with 1 left over, that's 74 point, is it 93? That's not right. 74 is not right. 72, 13, 76. How about 76.93? Okay, feet squared. Now that is just a half circle. So now we have to add these two together. There's step 3, 112 plus 76.93 is 188.93 feet squared. Okay, a little more difficult there, all right? One, because we have two shapes, and then we have this half circle as well. All right, next one. Okay, so this one is also difficult because here we have a trapezoid on the outside with a circle on the inside, and we have to know that the height of this trapezoid, this height is equal to 8. All right, here are your two bases, 11 and 9. Here's the height of the trapezoid, and they only give us this radius of this circle, which we need for the circle, but you have to know that we have two 4s here. So the height is 8, so we're going to do the area of a trapezoid, which is add the bases, that is 20, times the height, which is 8, divided by 2, which is 160 divided by 2, so the area of the trapezoid is 80. Number 2, the circle is pi, 3.14, times 4 squared, which is 16, and that is 50.24. And for number 3, we have to subtract these two. 80 minus 50.24 is 29.76 yards squared, which is the area of the shaded region. Okay, so area of the trapezoid, the whole thing, subtract out the area of the circle, and you have the area of that shaded region. There's your notes for today.